Hey everyone, welcome back to the channel Unlocking Data and AI. I am Krishna, a data scientist, and today I wanted to break down something that's been bugging me for quite some time. Why most AI initiatives never reach production. Most AI projects we have heard about, read about, or worked on never actually reach to production. And that's not an accident, it's a pattern. If you are an architect designing AI systems, a business leader funding them, or a technologist trying to ship one, this isn't just an AI team's problem, it's directly affecting you too. By the end of this video, you will learn exactly which of six recurring failure point is killing your project and what to do about each one of them. And trust me, it is worse than you think. The enterprise AI reality check, guys, 88%. That's the percentage of AI pilots that never make it into production. According to IDC's research conducted in partnership with Lenovo and published in 2025. Think about what this actually means. For every 33 AI POCs a company launches, only about 4 makes the journey into production. You might look at this number and rethink, okay, maybe this is just one study. It is actually not the case. Look at the three other similar studies on the right. Gartner's April 2026 survey of I&O leaders found that only 28% of AI infrastructure use cases meet ROI expectations, with 1 in 5 failing outright. MIT's Project Nanda takes an even harder look at the problem. Their research found that 95% of Gen AI pilots delivered zero measurable ROI. So even when an AI project actually make it into production, shipping it doesn't necessarily means it's creating business value. And then there is GDN's 2026 AI infrastructure report, which found that 54% of organizations have delayed or cancelled an AI initiative in past 2 years for different research firms, 4 different angles, same wall. And we are seeing the same pattern from different directions. Some initiatives never make AI initiatives from POC to production. Some makes it to production but doesn't deliver the expected ROI, and some don't even make it that far. They get delayed or cancelled altogether because enterprise AI doesn't have a POC problem, it has a production problem. And beyond production, it has a business value problem as well. The technology is moving incredibly fast. The models are getting better. The infrastructure is becoming more accessible. So, why the enterprise is still struggling to turn AI experimentation into sustainable business outcome? That's the question I wanted to explore today. And I believe the answer isn't simply about the AI technology, it's about the gap between AI ambition and enterprise execution. We know AI initiatives are struggling to make it into production and generate value. But there is a deeper question. Is this really an AI technology problem or something else? BCG's Build for Future 2025 study gives us an interesting way to look at this problem. The study, they studied 1,250 senior executives and AI decision makers across industries, assessing organizations across 41 different AI and digital capabilities. And when you look at the maturity curve, some interesting facts are obvious. As per BCG's study, 14% of organizations are stagnating, means they are taking minimal or no meaningful AI actions. 46%, the biggest group, are still in emerging stage. That means they are experimenting, they are running business pilots, they are building capabilities, but they are not yet consistently capturing business values. Let's stop here for a second and rethink. 60% of organizations are either stagnating or still struggling to turn AI activity into meaningful value. Now, look at the next level. 35% of organizations are scaling AI. These organizations have moved beyond isolated experiments. They are deploying AI across functions and beginning to generate values. BCG study describes this group as scaling their AI effort and starting to capture values. But then comes the number that really caught my attention. Only 5%, just 5% are what this study calls future build. They are organizations that aren't simply deploying AI, they are building the organizational capabilities to continuously create value from AI at scale. And BCG's study found something even more interesting. These future build companies achieve 5 times the revenue increases and 3 times the cost reductions from AI compared with others. So AI works for 5% company and doesn't work for other 95%. Is this correct? This may not be the correct interpretation of this study. The story is more important than that. The organizations getting disproportionate value from AI have built a different level of maturity around it. They have the strategy, they have the operating model, they have the technology and data foundations, they have the people and leadership capabilities, and critically, they know how to move from experimentation to scale. Let's understand why a proof of concept is not always equivalent to production. A POC typically runs on a small hand-picked data sets with a human review every output. It's usually used informally by a single team, often running from a notebook or someone's laptop with little or no pressure around uptime, latency, or cost. Production is completely different environment. Now we are dealing with messy, real-time data at scale, automated monitoring, and guardrail instead of constant human interventions, potentially thousands of concurrent users, governed and secured infrastructure, and hard SLA around availability and latency. And that's the key point. These are not simply two versions of the same project. They are close to two different engineering problems that happens to share the same model. So let's break down exactly where the gap can derail your AI projects. Given are some of the major reasons why AI projects stall before reaching production. We will cover 6 key areas that can make or break an AI project in production. The first one is the data readiness, the data problem. The second, unclear business cases, the ROI and ownership problem. Third, MLOps and infrastructure gap, the engineering problem. Fourth, governance and security, the compliance and risk problem. Fifth, change management, the people and adoption problem. And finally, model drift and monitoring, the challenge that starts after launch. Have you noticed something interesting? Only one of these 6 is really about the AI model itself. The other 5 are organizational, process, engineering, or operational gaps. That's the core thesis of this discussion. So let's start with the foundation of every AI system, and that is data. Reason 1 of 6, data readiness. Teams build the model on a small, clean, hand-picked data set and shocked when the model struggles on the real production data that's messy, incomplete, and constantly changing. Let's discuss few of the data challenges in details. Hand curated training data doesn't reflect real world input. There is no unified pipeline actually connecting the model to live source system. Data quality, labeling, and lineage were never formalized, so nobody can even diagnose failures. And real-time or streamlining access was never designed at the start of the project. So the model works great on a studies, data snapshot, and nowhere else. In February 2025, Gartner made a striking prediction. Through 2026, 60% of AI projects without AI-ready data would be abandoned. And now we are well into 2026. The industry evidence suggests that this prediction may be playing out in the real time. Reason 2 of 6, unclear business requirement. This is arguably the most common and most avoidable failure. The project was never anchored to the business outcome in the first place. Nobody defined an ROI target or success metrics before the build started, so there is no way to know if it worked. The POC gets judged on how impressive the demo looked, not on any business KPIs. No single person in is accountable for actually realizing the value after launch, and data science and the business side never ever agreed on what problem they were solving. A very interesting study by Gartner 2024, 49% of organizations say estimating and demonstrating AI business value is their number one barrier in AI adoption. Reason 3 of 6, MLOps and infrastructure gaps. Guys, a notebook that works on a data scientist's laptop is not a system. No CI/CD pipeline means every deployment is a manual, error-prone, one-off event instead of a repeatable and streamlined process. The code itself was never engineered for scale, error handling, or reliability. It was written to prove an idea, not run in production. There is no parity between dev, staging, and production environment, so works on my machine becomes a running joke these days. And there is no versioning discipline for models, data, or experiments, so nobody can reproduce or roll back a bad development. Reason 4 of 6, governance and security. This is the one that blindside teams late, means everything technically works and then legal security or compliance stops the launch cold. Model risk and compliance only get reviewed after months of engineering works are already sunk, instead of in parallel from the day one. There is no audit trail or explainability, which is a hard blocker the moment a decision affects a customer or the end user. Data privacy review happens too late in the process to actually influence the architecture, so fixes becomes expensive rewrites instead of design choice. The security effectively vetoes the whole approach right at the finish line. This is exactly why finance and healthcare, the most regulated industry, see the steepest drop off between POCs and production. If security and legal aren't in the room during design, they will be in the room during the post-mortem instead. Reason 5 of 6, change management. This is the most human reason on the list and often the most underestimated by the technical team. The people who will actually use the system day to day were not involved in designing and workflow around it. The disruption to the existing processes was badly underestimated. A great model dropped into a broken workflow still fails. There is no real training or support plans for the humans expected to adopt it. And trust quietly erodes when decisions feels like an unexplainable black box. So people quietly round around the system instead of using it. Gartner study 2026 state 57% of leaders who had an AI project fail says it's because they expected too much too fast, which is really a change management and expectation setting failure dressed up as a technology failure. The best model in the world loses to the mediocre model people actually trust and use. Region 6 of 6 models, drift and monitoring. The one everyone forgets. Shipping to production is not the end of the project. It's the start of a new phase of ownership. There is no monitoring for the data drift or concept drift after launch. So nobody watching as the real world diverges from what the model was trained on. Performance slightly silently degrades. There is rarely a dramatic failure, just a slow erosion of accuracy that goes unnoticed. There is no feedback loop to retrain, recalibrate, or retire the model when it's no longer earning its keep. And critically, nobody explicitly owns the model post launch. It becomes an orphan asset in the organization. As per a study performed by S&P Global, 42% of companies abandoned most of their AI initiatives in 2025, up sharply from 17% the last before. That jumps is largely organizations finally admitting their production system were quietly failing all along. Now that we are looked at the six major gaps that can derail AI projects, let's turn them into five practical shifts that can help us get AI into production successfully. First, design for production day one. This directly counters the MLOps and infrastructure gap. We need to think about scale, security, and data flow before the first pilot even ships, not when we are already trying to move into production. Second, define success metrics first. This addresses the unclear business case before we start building. We should agree on the business KPIs that determines whether the project is a go or a no-go. Success should be measured from day one, not something we try to define after the solution is built. Third, build MLOps early. CI/CD versioning, monitoring, evaluation, and observability shouldn't be added at the end. They should be a part of the development lifecycle from the first prototype. This makes the transition from POC to production much smoother. Fourth, involve governance upfront. Security, legals, compliance, and risk teams should be part of design process, not brought in just before launch. Addressing these requirements early prevents costly redesigns late. And fifth, co-design with end users. This addresses the change management problem. The problem who will actually use the AI solutions should be involved in building it from the day one. Adoption shouldn't be left until the end. It should be designed into the solution. And here is the key takeaway. None of these five things are particularly hard. The problem is that they are usually done in the wrong order. So the shifts is not about building more AI. It's about building AI differently from the very beginning. The POC was never the hard part, production is. At the end of the presentation, everything we covered comes down to one thing, closing the gap between POC and production. In the upcoming videos, I will go deeper into each part of this framework, from building effective MLOps pipelines to conducting a proper data readiness audit before a pilot even begins. So if you want to go beyond the POC and learn how to build AI that actually survives in production, subscribe and join me for the next one. And one question for you, which of these six reasons is hurting your AI projects the most? Let me know in the comments. See you in the next one where we take AI from prototype to production. Thank you for watching.